All right, hi everybody, and thank you for joining us today for our webinar, The Science Behind the Health and Safety of Fiberglass and Mineral Wool. My name is Kim Melton, and I'm going to be the moderator and co-host for today's presentation. Before we get started, I do want to thank you all for joining us and let you know that, like many of you, we are working from home as our city here in Denver is on shelter in place. So if we have any technical difficulties or if there are any problems or disconnections from the webinar today, we will do a recording for you and send out the recording to everybody here who is attending today. So please bear with us if there are any technical difficulties. Now, before we get started on introductions, I do want to go through a couple of logistics. We will be answering all of the questions in a Q&A at the end of the webinar. You should see a Q&A feature to the right side of your screen here. If you don't see that, if you hover over the center of your screen, you'll see a bunch of little circles near the bottom. There's one on the right side there that has 3 dots across it. It's an ellipsis. If you click on that, it will open up a Q&A feature in the menu there. And you click on the Q&A, that'll open the Q&A feature to the right side of your screen, and you can use that to submit any questions you may have throughout the webinar, and we will address those live at the end. So one note today, this webinar is for educational purposes only, and it shouldn't be used as a substitute for professional engineering design, consultation, or documentation that might be required by building codes, contracts, or applicable laws. So if you have any questions after this webinar, you can actually refer to our specific application guidelines and instructions, and those are located on the product sections of our website. Now, additionally, we will be following today's webinar with a survey, and this is your opportunity to provide us with feedback for how we did today. You can ask any additional questions you may have about the topic of the webinar, or if you want, you can even suggest future topics. But this survey is part of how we deliver the JAM experience to you. And you'll see the JAM experience there in the bottom left side of your screen. That's people, passion, perform, and protect. And we offer webinars like this one to help educate the market and offer a tool and a resource for you and your business. But we understand that this isn't just a one-way street, and your feedback is actually a key component to helping us evolve to better meet your needs. So if you have any comments or suggestions as to how we can better accomplish this, or maybe even feel like we've missed the mark today, we'd encourage you to fill out the survey. We'll use your feedback to improve our webinars in the future and provide the information that has the most valuable to you. We are also frequently asked whether or not we send out these webinars. While we don't send out the webinar from the deck itself, we will post a recording of this online for you to watch in its complete context. So with that, we'll go ahead and get to introductions, and I will hand it over to Bruce Ray to introduce himself.
Thank you, Kim. Thank you, Kim. Great to be here again today. This is Bruce Ray. I'm Associate General Counsel for Governmental and Regulatory Affairs with Johns Manville. As you see, I've just completed my 30th year at Johns Manville, and I have had a focus in my career on fiberglass and mineral wool hazard and regulatory issues since the early 1990s. And then just before that, might be interested to know, I did work for a number of years at the Environmental Protection Agency, really with a focus on Superfund work there, where a lot of it is devoted to exposure, hazards, and risks.
Excellent. Thank you, Bruce. And like I said, I am Kim Melton, and I am the Associate Content Manager here at Johns Manville. I haven't been here for quite 30 years. I'm going on 6. And I work largely in insulation systems, developing their educational and technical content, and that includes content for building insulation, HVAC, mechanical, industrial, and OEM insulation. So with that, we'll cover off on a couple of basics. Now, this field of study is got a vernacular surrounding it that we wanted to go through at the beginning of the webinar to make sure that you know what we're talking about when we refer to some of these terms. So the first term, and probably the most common here, is going to be the synthetic vitreous fiber, and SVF for short. And basically that refers to all forms of manufactured inorganic fibrous insulations, including glass wool, and mineral wool, also rock wool and slag wool, as you might have heard it called. Another word for an SVF fiber is man-made vitreous fiber, or MMVF. Also, you'll find that we have biosoluble fibers. Now, these are the types of fibers that are capable of being dissolved in the lung in vivo after they've been inhaled at a fast enough rate that it's not going to cause a health hazard, except for perhaps some temporary. We also have a biopersistent fiber, and these are typically capable of being dissolved in the lung, but at a much slower rate, and they could pose a potential health hazard to person or animal that hasn't inhaled it. The fourth term I want to talk about is the K-dis, and this is called your dissolution constant. So it's an in vitro measurement of synthetic fiber biosolubility in simulated lung fluid, and it's used to predict in vivo biosolubility. So we use this to determine how quickly a body is actually going to be able to dissolve a fiber in a lung. The next word we have is macrophage. This actually is Latin for great eater or giant eater, and what it is basically, it's a scavenger cell, and you have them all throughout your body, and you have them in your lungs as well. And this cell is responsible for basically finding and ingesting any inhaled foreign particles in your lungs, and then making sure that your body can get rid of it. Part of your immune system, and very, very helpful. You have a special purpose fiber, SPF, and these are glass fibers used for non-insulation special applications. They're not very common. They're in about 1% of all glass fibers manufactured. They're used for things like filtration, battery separator paper. These are not fibers that the general public can buy. They're used in highly, highly specific applications. Next, we have IARC, and this stands for the International Agency for Research on Cancer. They're part of the World Health Organization, and they are the keeper of the International Carcinogens List. The NTP is basically the U.S. version of IARC, and it's the U.S. National Toxicology Program. They're part of our Department of Health and Human Services, and they're the keeper of our official U.S. carcinogens list. So these are some of the terminology we'll be using today. If you have any questions, again, you'll be able to refer back to this when we post it live online. So before we get started, I want to talk a little bit about the hierarchy of data used to determine a hazard. Now, if we look at the bottom, we have chemical data, and this chemical data basically allows us to identify how something is going to respond based on its chemistry. So we might be able to say we know how glass is going to respond in a Gamble solution, a simulated lung fluid, because we know how the chemistry reacts here. When we're determining a hazard to humans, this data is relevant, but it's lowest on the hierarchy of importance. Next, we have in vitro data. So this actually stands for more of our simulated studies where you have your Gamble solution, you have your fiber, you put it in, you see how they respond. You're not looking at something that's in a living creature, but you are looking at something that's in a lab setting that's very, it's designed to replicate what you would encounter maybe in the real world. This is your next on your hierarchy. Above that is animal data. This is your in vivo testing. This is a testing that's really important because you're actually able to use it to potentially identify what would happen if it were actually in the human population. So this data is very important and plays a large role in determining whether fibers are hazardous. And then finally, we have the human data, the human epidemiology data. Now, this data is the most important in terms of what we're looking at and what holds the most sway in determining whether or not a material is potentially hazardous to human health. So why are we, as Johns Manville, here today? Our industry has a very specific approach to synthetic vitreous fiber hazards, and it's in the acronym of IPC. And I stands for investigating the possible hazards, and this is done via transparent scientific studies. The P stands for publishing in that, and we are committed to publishing the results from those studies and communicating, C, any hazards we may find, the results from the studies, good or bad. So our objective here is to communicate what the studies are finding and make sure that people are educated about any potential hazards with the products that we're making. So with that, I'm going to hand it over to Bruce to talk a little bit about where we are today.
Thanks, Kim. We're not going to keep you in suspense. We're going to get right to the ultimate conclusion of where we are today, and that is this. The glass and mineral wool fibers that are used today for insulation purposes are not classified as carcinogens. We developed a large body of science in the 1990s that has been recognized by not only international but national authoritative scientific bodies, and based on that science, we have clearly shown that these insulation fibers do not have a possible cancer hazard. What it means then is also these products, these fibers require no cancer warning, and that is addressing the hazard. So we have a low hazard or no possible cancer hazard by inhalation. The good news too, and we'll explain this later on, the indoor air exposure to glass fibers is actually very low, and not just in manufacturing, as we'll talk in a bit here. We do have some actual studies and data in both indoor residential settings as well as indoor commercial settings. Now, I've given you the ultimate conclusion here, but I think I want to, as they say, show our math, let you know how we got to where we are today. It's important that you understand that there were some initial studies that were done 40 and even up to 50 years ago. These were done by two researchers, Dr. Pott in Germany, Dr. Stanton in the United States. we see these names because sometimes even today, people will say, oh, well, we understand that Dr. Pott did a study, Dr. Stanton did a study that showed that glass fibers cause cancer. What we need to do is understand that those were done a long time ago, and those were done in what were called IP, or intraperitoneal implantation studies. What they did is they, these unfortunate guys, they would cut open their peritoneum, they would stuff fibers in, sew it back up, let them run around for a year, and then they would look at, they would cut them back up and look at the peritoneum, and unfortunately, there were tumors that were found when they would do that. Kim talked about the International Agency for Research on Cancer. This is the authoritative international body that's the official keeper of not only substances but exposures that might present a cancer hazard. As you can see here, they have a classification scheme by which they group possible cancer hazard from group 1, known carcinogen, all the way down to group 4, probably not carcinogenic to humans. When IARC looked at these Pott and Stanton studies, the intraperitoneal studies in 1987, they put those studies in their classification matrix. As you can see here, IARC determines a potential cancer hazard based on both looking at the animal data and then looking at the human data. The human data for glass fibers and mineral wool fibers had always been inadequate, and it was judged so by IARC. The real question, though, was what were they going to do with those early IP studies? And because those were really the only ones around for glass fiber, they judged that at the time that those studies were sufficient. And you can see there, by having inadequate human data and sufficient animal data, that puts you in a group 2B, which is a possible carcinogen. And the problem with that is that although IARC back in 1987 recognized that the IP studies were done basically administered by a route of exposure that wasn't relevant to what happens in humans, they nevertheless thought that's all they had, and so there were no what they called well-designed animal inhalation studies, and so they just went with those early IP studies. Now, in the United States, there was a definite impact of that Class 2B classification decision by IARC in 1987. Under the OSHA Hazard Communication Standard, IARC is recognized as an authoritative scientific body, so that if IARC recognizes a substance or an exposure as a possible carcinogen, that has to be reflected as part of the company's compliance with the OSHA Hazard Communication Standard. In addition, OSHA also recognizes the National Toxicology Program, as Kim explained early on, and in 1994, the NTP essentially recognized in a formal way IARC's 1987 Group 2B possible carcinogen listing, and so that by the time, say, in the early 1990s, because of OSHA HAZCOM, these fiberglass insulation products had to have a cancer warning label on them, basically explaining that it could present a possible cancer hazard. The industry found itself in the late 1980s of having IARC classify the products and the fibers as Group 2B possible carcinogens. And the IARC's admonition to the industry was, well, we can't make any decisions on inhalation hazards because there's no well-designed animal inhalation studies. And so the industry, the fibrous insulation industry, back in the late 1980s and early 1990s, set about designing better animal inhalation studies. And in the industry then, in consultation with scientists in academia, also industrial hygienists and governmental agencies, developed these inhalation study protocols for animals. And we set about doing long-term animal inhalation studies then. They were conducted at research consulting company in Geneva, Switzerland, starting in about 1992. There were two species of animals that were part of the inhalation studies, rats and hamsters. It's important to have hamsters because they are thought to be more sensitive. In addition, we tested three different kinds of fibers. First, the insulation fibers, both fiberglass and mineral wool. As Kim said, the special purpose fibers. These are the small amount of fibers that are made and used for non-insulation purposes. And then we used, of course, asbestos. Now you have to test with asbestos because it would serve as a positive control that if you were going to get any kind of delivery of those fibers into the lungs of these test animals, if you did it with asbestos, you'd know that you were getting those fibers in where they needed to be. This was a 24-month exposure, which is, essentially the entire lifetime of these animals. And what we did was we had both an interim, several interim, as well as final tissue analysis, where they would count the fibers in the lungs, and then, of course, they would have a very close microscopy and radiology effort to look at fibrosis and tumors in these exposed animals. The results of these studies is that for the control animals that were exposed to asbestos, they got tumor proliferation. So that really helped us confirm that the way that we designed the inhalation mechanism, that we were getting lots of respirable fibers in the lungs of these test animals. For special purpose fibers, these are the ones used, for example, for some specialty filtration and battery separator paper applications. We did get some fibrosis in tumors, but universally for the insulation glass wools and the mineral wool fibers, we got no fibrosis and no tumors. And we actually learned a lot, a great deal from this long-term study. And one of the observations that we made that was counterintuitive was that some of the interim analysis of the lung tissue, especially towards the end of the study, these animals would have a higher fiber count in their lungs than after the initial exposure. As I said, it was unexpected, but it turned out to be one of a key mechanism by which we were going to identify fiber-based carcinogenesis. Here's another one of the most important slides in the presentation today, and this is the conclusion from the long-term animal studies. The most important thing that we learned from these animal studies was that the potential cancer hazard of a glass fiber or mineral wool fiber is controlled by the 3 Ds: dose, dimension, and durability. And you have to have all 3 of these present at the same time for the same fiber in order for there to be a potential cancer hazard. Dose refers to the ability of these fibers to be deeply respirable. And we know from calculations based on what we call the aerodynamic diameter of fibers, it's a very interesting physics issue that if you get a fiber that's long, if it's thin enough, it actually behaves like a particle in the lung and is therefore deeply respirable. The dimension is also very important. So we're looking at fibers that are longer in length than a macrophage scavenger cell is in diameter. So a macrophage is around 20 microns in diameter. So it's those fibers that are longer than 20 microns that are part of the dimension issue here. But also, most importantly, is durability. So that if you have a fiber, only if you have a fiber that is deeply respirable, longer than a macrophage is in diameter, and durable in the lung, do you get a potential cancer hazard. No one knows exactly for sure, but we understand what happens in the lung if a fiber is deeply respirable, if it's longer than a macrophage is in diameter, and if it's durable, it persists in the lung. It can cause chronic inflammation. Inflammation then causes cell repair or proliferation, which can lead to fibrosis and also to tumors. And we also, so in addition to the 3 Ds, we also learned, why insulation, glass, and mineral fibers are biosoluble. as Kim mentioned early on, it has to do both with their chemistry as well as their morphology, their shape. This is one of my favorite slides in the presentation, and it really shows you in a stylized way what happens when a long fiber is dissolved in the lung, especially a biosoluble fiber here. Now you can see that you start with a single long fiber, and it can go either to a congruent dissolution that is equal around on the left, or it can go to incongruent dissolution. We do have this phenomenon where congruent dissolution can lead to complete dissolution. It basically just dissolves completely. But we also learned that these longer biosoluble fibers can undergo what's called incongruent dissolution. They break transversely. And so that you can see there, you can have one long fiber that's being broken up into 4 short fibers. And that's what I meant when on the earlier slide, where we saw that actual fiber structures were increasing over time in the animals. We didn't know exactly what that meant until we did some more study, but it really meant that what's happening is that those biosoluble fibers were actually undergoing transverse breakage in the lung. Once that happens in transverse breakage, you can get a fairly easy macrophage uptake, and those fibers are then cleared out of the lung via what they call the mucociliator escalator. So that's what we learned in the long-term animal studies. We want to do for you a bit of an animation that kind of shows what happened when these fibers are deeply respirable, and we'll show this first for a durable fiber, and then we'll show it for a soluble fiber. So if you get a durable fiber in the lung, the macrophages try to engulf the fiber. The problem is these fibers are longer than the macrophage is wide. And in the process, what happens is the macrophage actually dies, and then low pH enzymes are released. The low pH enzymes, again, along with the fiber, it causes inflammation, which causes cell proliferation, which can cause tumors and fibrosis. Now let's compare that to what happens with a biosoluble fiber. You have the same macrophage that tries to envelop a biosoluble fiber. And what happens here is that fiber actually breaks. It undergoes that the incongruent dissolution and breaks that longer fiber into smaller parts that are then easily engulfed by other macrophages and then taken out of the lung. That's kind of a somewhat of a crude summary, but it shows you kind of from a animation standpoint what is happening in the lung when you inhale those fibers deeply. And Kim, I'll pass it over to you.
Thanks, Bruce. So Bruce talked about animal inhalation studies, but like I said, they also wanted to take a look at the human side of it and the human epidemiology study for fiberglass and mineral wool. Now, obviously, we did not subject humans to the same test methods that we did for animals, but what we did do is we took a look at death certificates for an exposed population of fiberglass and mineral wool manufacturing workers to review their cause of death. And we compared these fiberglass and mineral wool manufacturing workers and their causes of death to the unexposed population, basically with the objective to determine of whether or not these exposed workers had a higher rate of respiratory system cancers or even non-malignant respiratory disease than your general population. Now, what's really fascinating about this study is a couple things. First, it accounts for nearly 1 million person years of exposure over an exposure period of almost 50 years. So when we're looking at the statistical significance of this, we have a lot of data here, which allows us to get a very robust look at what is actually happening in terms of long-term exposure rates to fiberglass and mineral wool, and is it actually impacting these people? When you compare it to a study of, say, 10 people over the course of 5 years, you're not going to get data that's as robust as the data that this study was able to explore. Now, what the study found is that the respiratory system cancer rates were not higher in the exposed population after you controlled for confounders like smoking. Also interesting here was that the duration of exposure or the cumulative exposure of respirable fiberglass or mineral wool wasn't associated with an increased risk of respiratory system cancers. So somebody who worked at a plant for 50 years did not have an increased risk of respiratory system cancer compared to somebody who worked there for 1 year or 5 years. There wasn't an apparent trend with increasing exposure. So as of 2001, we have conclusion from both types of studies. We have a conclusion from an animal science-based study that Bruce just discussed, where we're actually looking at what happens when these animals inhale glass fibers and then mineral wool fibers versus what happens when they're implanted in like the stomach lining. And this study demonstrated that insulation synthetic vitreous fibers are sufficiently biosoluble that they have no cancer hazard. As of the human epidemiology study with over 1 million person years and nearly 50 years of exposure, it also confirmed that the rate of respiratory system cancers in fiberglass and mineral wool manufacturing workers wasn't higher than the unexposed population. So with that, Bruce is going to talk a little bit about what happened next with IARC.
Thank you, Kim. As of 2001, we had developed the animal science, as we discussed, and we had an update to the Epi cohort study that Kim discussed. So we went back to IARC, and you can see that we got a change in classification here. Whereas previously, the human data has always been inadequate. What the big issue that we had, and the big result out of IARC, and when they reconsidered all the data in 2001, is that they moved it from sufficient in animal to limited in animal, and that caused a reclassification from 2B, possible carcinogen, to 3, not classifiable. So the result of the IARC looking at all the new data, all the new science in 2001 was they took fiberglass, insulation fiberglass and mineral wool off the possible carcinogens list. We talked a little bit also about the National Toxicology Program. As we said in 1994, NTP followed the 1987 ruling by IARC and classified glass wool fibers as reasonably anticipated to be a carcinogen. Took a decade after 2001, but NTP did then reclassify the biosoluble fibers and remove those from its official list of carcinogens for the United States. And one of the issues that we always kind of come up against is that the IARC and the NTP got to the same conclusion, but they used a little bit different reasoning. IARC, when they reclassified fiberglass in 2001, they basically said insulation, glass wools, and mineral wools are no longer a potential cancer hazard. NTP came at it from a different route, really. They basically said in their updated substance profile, and this is from July of 2011, they're saying that all of these glass wool fibers are presumptively still potential carcinogens. That is, unless they're exonerated by an animal test, such as the one that we did and that we described earlier, these RCC tests. And you can see that even the name of the substance profile was changed from glass wool fibers to certain glass wool fibers. And so basically, it means that if you've got a glass wool fiber that's been exonerated in an animal test, which all of the insulation glass fibers, all the insulation glass wool fibers are, then they're not considered to have any kind of cancer hazard in the United States, and that's under NTP. And this is a distinction between SPF and insulation wools. Of course, in the United States, there's yet even another step, and that is the law in California that we love to hate, Proposition 65. Under Prop 65, any chemical or substance or exposure that is quote unquote known to the state of California to cause cancer has to have a Prop 65 warning on it. When we went and met with the OHIA officials in California, explained to them what IARC did in 2001, what NTP did in 2011, they also followed that. And basically now, if you look, it's only those respirable durable fibers, the non-insulation fibers, that are still considered carcinogens under Prop 65. I want to let you know that we have some very important updates on epidemiology. As Kim stated early on, it's that human epidemiology data is the most important type of data. It has the most power in terms of helping you understand the hazard. and we've got some updates. And this is one of the main reasons that we wanted to have our webinar today, is to explain to you some very interesting updates that are happening. The first Epi update was done in 2009. It was done by Dr. Marsh, who was the principal investigator of the 2001 cohort study update. He looked at everything, all of the Epi studies that took place between 2001 and 2009, and he came to the conclusion that IARC's decision to remove insulation glass wool from its possible carcinogens list was still valid, and this was, importantly, this was accepted by the National Toxicology Programs, both its expert panel as well as its Board of Scientific Counselors, and was very important in getting NTP to remove biosoluble glass from their list of carcinogens. More recently, we have two very recent updates to tell you about on the epidemiology. Just later last year, Drs. Egnott and Marsh completed a quantitative statistical meta-analysis of all of the cancer epidemiology studies that were published in journals after IARC did its reclassification in 2001. And there were quite a few. They went through all of them, did the analysis. Their ultimate conclusion is essentially no consistent or credible evidence of an association between man-made vitreous fiber exposure and respiratory tract cancer. We're using a little bit different terminology now. Instead of saying respiratory system cancer, we're saying respiratory tract cancer. But the upshot is still the same. IARC's 2001 removal of insulation fibers from the possible carcinogens list is still valid. And you can see down in the fine print on that slide a reference to this study. It will be published shortly in the prestigious peer-reviewed journal, Regulatory Toxicology and Pharmacology. You can see there, it may already be up, but it was supposed to be for publication in the April edition of Regulatory Tox and Pharm. And I would add that typically Regulatory Toxicology and Pharmacology is an Elsevier publication. You know, you have to either buy this article or you have to have a subscription to Elsevier. The industry has essentially paid for this to be an open article so that anyone can access this on Elsevier for free. Here's something that we're also very excited about. So we did not just an update of the cancer epi, we also did an update of the non-malignant respiratory disease epidemiology. IARC in 2001 stated that there were no studies showing that exposure to insulation, fiberglass, and mineral wool caused not just cancer, but it also did not cause non-malignant respiratory disease. And so we now have a study that has just been completed. Again, it is a quantitative statistical meta-analysis of all of the non-malignant respiratory disease studies that were published after the IARC 2001 classification. And these are two different types of studies. One is an epidemiology study that looks at mortality, and the other is a more sort of a morbidity that is a non-mortality study. This, you can see in the fine print on the bottom here, was supposed to be presented at the Science of Toxicology conference in Anaheim last week, but of course everything is canceled. So we're waiting to see where this is going to actually be published. But the conclusions are that first on the epi, on the mortality side, that workers exposed to these fibers do not experience an increased risk of mortality from non-malignant respiratory disease compared to the general population. And then on the non-mortality, the morbidity part, the overall suggestion is that occupational fiber exposure is not associated with lung function reduction or in pleural plaques. So very, very excited that we have those two epi updates. And as Kim explained, This is all part of, we investigate, we publish, and then we communicate. And so these are going to be published soon, and then we will be pushing some communications out on these.
All right. Well, I'm going to take over now and talk a little bit about exposure levels. Obviously, you know, we talk about what's happening when it's in your system, but a lot of people have questions about, well, I'm working with the material, I am working in a manufacturing facility, it's in my house, I'm a contractor, I'm specifying this stuff. Is it actually being, in these environments, am I being exposed to it in great amounts? And that's a great question. And it's one that NAMA, the North American Insulation Manufacturers Association, actually takes very seriously. And part of their product stewardship is maintaining this robust database of occupational exposure for industrial hygiene. And so what they've done is they have, as of 2020, more than 18,000 industrial hygiene data points for people who are working with fiberglass and mineral wool insulation in a variety of environments, so manufacturing, installation, retrofit, removal, and fabrication. And the findings from this report are actually show that most of the people interacting with fiberglass or mineral wool are generally exposed to very low fiber levels, less than 1 fiber per cubic centimeter. And that 1 fiber per cubic centimeter is relevant because that's the OSHA NAMA voluntary permissible exposure limit. And that's basically at that point when you've got more than 1 fiber per cubic centimeter, you might want to put on an insulation dust mask to cover to help prevent temporary mechanical irritation of your lungs. But that's a pretty dramatic amount of fibers in the air. So when they actually look at the actual numbers of the study, they found that the mean exposure levels for every insulation industry sector were below 0.4 fibers per cubic centimeter, and the medians were all below 0.2 fibers per cubic centimeter. Even when you look at the top end of the line, even in the 95th percentile, the highest exposures were actually well below the 1 fiber per cubic centimeter voluntary exposure limit. And so really what we're looking at is when you get fiber concentrations greater than 1 fiber, it's typically only in blowing wool installation applications where you're literally blowing the fibers into the air to have them settle over a broad surface. So that's the working side of it. But what about the people side of it? What about the homes and the commercial buildings and the office buildings? How many fibers or what types of fibers are people being exposed to in those environments? Also a good question. So there was another study that was done by Carter et al. And this study actually counted and speciated fibers in indoor environments using optical and electron microscopy. And the reason they wanted to speciate these fibers is because they wanted to determine which fibers are organic in nature and which one are these SBF fibers we've actually been talking about. Now, the results found that the fibers in indoor environments are actually generally quite low, 0.008 fibers, respirable fibers per cubic centimeter as a mean, and 0.029 as a maximum. Most notably, 97% of the respirable fibers that were accumulated in these indoor environments were organic in nature. So you're talking about fibers from drapes, carpets, dust, that sort of thing. The inorganic fibers, like fiberglass or mineral wool, made up less than 0.0001 fibers per cubic centimeter. Even more significant is the inorganic fibers were only present in 2 of 205 samples that were taken. So what we're actually looking at here is that you don't see a vast amount of fiberglass fibers or mineral wool fibers entering these indoor environments in residential and commercial applications, even in applications where their duct systems might be lined with a fiberglass duct liner. Now, the reason for that, and a lot of people have asked, does an Airstream of a fiberglass lined duct cause fiber shedding? And the simple answer to that is unlikely. So our duct liner insulations receive a UL. They receive a UL rating, and in order to get this UL rating, you have to expose the fibers to hurricane force winds. So we're talking about 15,000 feet per minute. Now the UL test requires you to test it at 2.5 times what the top speed would be encountered in an application. So our top speeds, our insulations are rated to about 6,000 feet per minute. But in order to get to pass this UL testing, we have to test it at 15,000 feet per minute, which is far greater than what you would encounter in a commercial insulation system or a commercial HVAC system. Now, significantly, to pass this UL testing, the insulation can't show any signs of delamination, shedding, or erosion. So what we find here is that even under really rigorous conditions, we're not shedding fibers into the airstream. Now, another side of this is that our fiberglass insulation duct liners are lined with permacoat coating, and this is an antimicrobial coating on the airstream surface. And this is actually designed to help protect the insulation surface from mold intrusion, but it serves a second purpose by preventing these loose fibers from entering the airstream. So the third part of exposure is outdoor environment. So where you have fiberglass and mineral wool manufacturing plants, are you seeing a significant amount of fibers in the outdoor area surrounding the plant? And no, the answer is quite simple. Fiberglass concentrations are very low around manufacturing plants, and they're typically about the same as the rural background. So with that, I'm going to hand it back to Bruce to talk a little bit about JM's policy on product stewardship.
Thanks, Kim. When I first started at Johns Manville back in 1990, it was very important to me to understand that Johns Manville had a strong product stewardship policy. And I would say Johns Manville really was there, because back then Tom Stevens, our CEO, made the following three commitments. He said, we're going to investigate the hazards of all JM products. Then we're going to communicate around those product hazards fully and on a timely basis with all employees. And our stewardship policy, if you could sum it up in one phrase, it was, we will tell you what we know as soon as we know it.
So that side of product stewardship isn't just unique to Johns Manville. It's actually an industry commitment to product stewardship. So our product stewardship, named as Product Stewardship Program, began as part of the Health and Safety Partnership Program with OSHA. And this program was designed to enhance hazard communication and education, just like this webinar today, maintain that comprehensive exposure database that I already discussed, establish the voluntary permissible exposure limit of 1 fiber per cubic centimeter, and then develop personal protective equipment or recommendations around any of the findings that we revealed from this research. And again, recommended respiratory protection was that N95 NIOSH dust mask that you see right there to the right side of your screen. And this is, like I said, you're only really going to account fiber concentrations that heavy when you're doing a blowing wool installation. Once these fibers have settled, it's not going to be in the air as a constant sort of thing. And you know, if you see those N95 dust masks on the store shelves, you want to grab them because they are in short supply right now. So talking about, well, what happens when I have inhaled these glass fibers? You'll typically get what's temporary mechanical irritation. And you're familiar with this. Anybody who's touched fiberglass on the skin, they know it's irritating to the skin. Same kind of thing happens if you inhale it. It can be irritating, but this is a temporary thing. It's not actually an allergic reaction. It's mechanical in nature. So even, you know, fiberglass and mineral wool are non-allergenic, but so are the durable glass fibers. So you're not seeing an asthmatory or a respiratory sensitization response to it. It's just a mechanical irritation.
Thanks, Kim. With all that in mind, what do we see in the future as far as fiberglass testing is concerned? We do know that there are a couple of definite trends. Probably the most important one is that the industry and the regulators, everyone, will be moving away from animal testing. We're seeing this in the EU, at the NTP, and even at EPA. There's actually a fairly large effort at the National Toxicology Program here in the U.S. That is looking at ways other than animal testing to assess the hazards of chemicals and exposures. And I think for fiberglass and mineral wool, what this is likely to mean is that we're going to get a lot less in vivo testing and a lot more in vitro testing. And Kim covered what that meant early on. Basically, to determine what the dissolution constant is in vitro of glass and mineral wool fibers, you essentially place these fibers in simulated lung fluid. The one that we use is called Gamble solution. It is a solution that actually tries to mimic the intercellular fluid in the lung. And then what you do is you bathe these fibers in the Gamble solution, and you measure the mass loss of the fibers over a specific period of time. And we have actually a fairly good body of data showing that there is a demarcation around K-DIS of 100, and that has become kind of an accepted threshold in the industry. The higher the K-DIS, the more soluble the fiber is, the quicker it disappears from the lung. Conversely, the lower the K-DIS, the more durable it is, the slower it disappears from the lung. And what we have done is we've looked at, Estes and Hadley looked at all of the animal studies that were done, and then compared which of those animal studies showed which fibers had fibrosis and tumors, which didn't, and then they looked at the corresponding K-DIS for those fibers, and they found that there was that K-DIS of 100, so that pretty much all fibers successfully tested and exonerated in animals had a dissolution constant greater than 100. And this was even endorsed by the NTP expert panel back in 2009. And so I think we're going to see further updates and studies and articles in the area of in vitro fiber testing. So let's talk about our ultimate takeaways for the webinar here today. And these are the conclusions, and we didn't keep you in suspense early on, and we're going to repeat them again here. These synthetic vitreous fiber insulations, glass wools, mineral wools, they really are the most tested insulations available. And we have demonstrated via human epidemiology studies, animal studies, in vitro studies, that there is no cancer hazard by inhalation for these insulation fibers. These fibers are also safe to manufacture and use, really when you use common sense precautions to prevent temporary mechanical irritation. Those precautions would be, let's wear long sleeve shirt, gloves, etc. And even though other insulations may claim to be safe, and we see this all the time, frequently it means only that they're untested, and so that there's no data to make a conclusion. And that's very different from our situation here with mineral and glass wool. We have lots of data. The data are compelling, and they support that there's no cancer hazard.
All right. Well, that concludes the main part of our presentation. I'm going to talk briefly about some additional resources where you can find some more information and some upcoming webinars that we have in the next month. First and foremost is the source. Now, the source is an online resource that has training. It hosts our blog. It hosts all of our recorded webinars and even specifications where you can compare products side by side. This applies for our HVAC, industrial, and mechanical products. On the OEM side, for anybody who's working in an OEM or works with OEMs, we do have the OEM Engineering Portal, and this is a portal we put together specifically for engineers who need information on product specification, sustainability information, tools, and then webinars that apply to the OEM sector as well as a brochure on the basics of sound control. For our building insulation side, for anybody who needs technical support, we have our Tech Connect team, and these guys are available online and on call, and up until about 2 weeks ago on site. As of right now, it's mostly online and on call, but if you have any questions or need help with any specifications, now's a great opportunity to connect with them online or give them a phone call. Speaking of Tech Connect, we will have what we're calling our 5 live webinar series coming up, and that's 5 webinars over the next 5 weeks. These are going to be basically mini webinars. They're going to be 30 minutes of really technical content with our spray foam and blowing wool teams, and they will be talking, they will open it up to questions after 30 minutes of presentation. So you can see there we have each of the topics we'll be addressing. And then in addition to the 5 live series, we will have an AIA-Certified webinar series coming up in April. And it's going to cover these 3 webinars: walls at work, architectural acoustics, and continuous insulation. And all of these webinars are certified for 1 credit, so it'll be 1 hour. And again, they will follow with a live Q&A like we have here today. So we will have a certificate of completion going out. This will go to everybody by Friday. It'll be in your inbox. And you can report this to AIA as it's a self-reporting course. It is certified. And so for anybody who attended today who's looking for those continuing education credits through AIA, you will have this. For anybody who's not looking for continuing education credits, will still get the certificate of completion for participating in today's webinar. So with that, we had a lot of questions submitted both during and before the presentation. So we're just going to go ahead and kick it off with our questions that were submitted before the presentation, and then we'll get into the ones that were submitted during the presentation. So Bruce, our very first question is, are there inherent hazards for installing both materials, referring to mineral wool and fiberglass?
The hazards of manufacturing, using and installing fiberglass and mineral wool are those related to temporary mechanical irritation. Those are easily addressed through proper protective equipment in the form of gloves, long sleeve shirt, long pants. We also recommend eye protection. We don't recommend respiratory protection with the N95 dust mask unless you're going to have fiber concentrations greater than 1 fiber per cc, and that's over an 8-hour, that's a weighted average over an 8-hour shift. And that's the concentration that is basically promoted by OSHA, as well as the insulation, the fiberglass insulation industry.
Excellent. The next question is an interesting one, and that is, why does the idea that fiberglass is a carcinogen still persist even after science has disproved it?
Yeah, good question. I think there's a couple of reasons for it, I think. One is that there are folks out there who don't know the science, and one of the ways that we deal with that is through webinars like this. And we do see, you know, on a fairly regular basis, manufacturers of alternative forms of insulation alleging that fiberglass and mineral wool supposedly have some sort of cancer hazard. I'll give them the benefit of the doubt and say they don't know the science, but sometimes they know the science and they're just making an inappropriate claim. I think, though, there's also some confusion out there between the different ways that IARC made its decision versus NTP. Remember, IARC in 2001 removed insulation fiberglass from its list of possible carcinogens, and they focused on the use, insulation. The NTP, a decade later, did not follow IARC in its reasoning. They just said, really, because by then the science was so well established about dose dimension and durability, so that rather than saying, oh, all insulation glass fibers are off the carcinogens list, NTP said, we're going to presume everything's a carcinogen unless it's been exonerated by an animal test. So I guess there are some people who read maybe the first couple of sentences of the NTP substance profile, and they say glass fibers are reasonably anticipated to cause cancer. They don't read the next paragraph that says it's only the durable fibers.
Excellent. So the next question is, are the exposure level results for discussion based on the air quality monitoring evaluation recently conducted by NEMA?
Yes. What NEMA, and this is one of the things that was part of the original product, the Health and Safety Product Partnership between our trade association NEMA and OSHA. We kept saying we think exposures are low. OSHA said, well, you better prove it. You have to have an exposure database. So we have a very comprehensive database. I think we have over 18,000 QA/QC'd IH database points in our database, exposure points in our database, and we are in the process of getting an article published that updates that database. And there were many samples that were collected really fairly recently, 2018, 2019. And you know, this is one of the things that we want to do as an industry. We want to make sure that we are updating the science where and when we can, and we're in the process of updating that, not only updating the exposure database, but updating a peer-reviewed journal article based on the database.
All right. The next question is interior duct insulation still a good answer for noise and air temperature losses? And I can actually answer this one. Absolutely. Fiberglass is an excellent solution for noise control, and certainly an excellent solution for temperature control as well. And then, as we discussed, you know, you're not seeing a proliferation of fibers in the airstream, and certainly in the air that people in occupied space as a result of lining ducts. So we would absolutely recommend that duct liner can still be used and should be used for noise and temperature control. That actually also answers the second one, which is it safe inside ductwork? Yes, it is also safe inside ductwork. Bruce, the next one is for you, and that is what would the product stewardship programs consist of?
We answered that. We had a slide on that. Product stewardship program is that first of all, we investigate the hazards, we communicate the hazards, and then we communicate ways to mitigate the hazards. And you see that's part of the stewardship program. We also look to see what the exposure is. So it's the hazard, it's the exposure, it's the protective equipment, and it's ways to avoid any kind of hazard. Those are kind of the core elements of the product stewardship program.
Excellent. So the next question is, which insulation is the best performer and which one should be specified above the other? This question really, I mean, there's no one-size-fits-all insulation for every solution. It really depends on the application. So, you know, fiberglass and mineral wool are both excellent for acoustics. If you want to look at your highest R value per inch, you're going to look at a polyiso board. It really depends on what you are looking to insulate and what you would like to do with it, what your goals are. So with that, we would definitely refer anybody who wants an insulation comparison. We could refer you to our website. There's plenty of information on there. And then if you have any questions, you can reach out to our Tech Connect team or our technical team here at JM. Bruce, I don't know if you know the answer to this one or not, but is spray insulation applicable in a residential attic space that's also being used for storage? And are there any respiratory risks after the insulation has already been sprayed?
I think, I mean, if you've got an attic space where loose fill fiberglass insulation has been blown between the rafters on the attic floor, one of the things, you don't want to compress that insulation down by putting, say, plywood down and then using it for storage, because then you'll get a diminution in the R value. Once it's in place, we really don't expect any kind of fiber exposure, though.
Okay. The next question is, what is the future of conventional insulation?
The future is very bright, right? No, I think fiberglass and mineral wool insulation have been around for a long time. They have a proven track record of thermal and acoustic performance as well as safety. So I think, you know, with that kind of history, I think the future is bright. So, and Kim, I know we're getting to towards the top of the hour, but we can stay on for additional questions. That's not a problem, I think, right?
Absolutely. So we're going to sit tight here. We will continue. We have a lot of questions that have come in, so we'll continue to work our way through this list. And if you have to drop off, all of these questions will be available recorded online. So, but thank you for anybody who has to leave now, and we'll continue on for anybody who would like to stay on. The question we have next is, how does the human body deal with fine glass particles or fibers that get into the lungs but are not exhaled?
We showed that in a couple of the slides for the biosoluble fibers that are used for insulation. Those fibers that are of such a, you know, the smaller diameter fibers that they're deeply respirable. It's really the, what they call the alveolar macrophages that we were talking about that actually will engulf the fibers, dissolve them, and then carry them out of the lung. So those biosoluble fibers, they either undergo what we had in that figure of congruent dissolution, where they basically dissolve to nothing, or they undergo transverse breakage, and then they're engulfed by macrophages and taken out of the lung.
All right. Is e-glass safe as well?
Yeah, e-glass is a special type of chemistry for glass, typically for electrical resistance and insulating. The hazard of any glass or mineral wool fiber, remember, is controlled by the 3 Ds. I know that, for example, Johns Manville makes e-glass, but they do it really as a reinforcement fiber. Those diameters on those fibers are so large, they're not respirable. So that even if you could, based on chemistry or whatever, understand that E-glass is more durable. If it's not respirable, there is no hazard there.
All right. The next question is, how does mineral wool thermal insulation compare to polyurethanes and polystyrene's thermal insulating values? While not applicable to the fibers and the health side of it, polystyrene has an R value of 3.6 to 4.2 inches per, or R3.6 to R4.2 per inch. Polyurethane, which is your spray foam, has an R value of about 7 inches per inch, R7 per inch. And then mineral wool is very similar to polystyrene at 4.2 to R4.3 per inch. So you're looking at very competitive products there in terms of R value. But, you know, when you're looking at product performance, you also need to look at the flame smoke rating. And so, you know, mineral wool has a 0 flame, 0 smoke spread, or smoke developed, I'm sorry. And whereas polyurethane and polystyrene have a higher flame and smoke rating. So, again, like I said earlier, those are just things you need to consider as you're selecting your material. The next question is, can I get credit hours for this webinar? The answer is yes. This is an AIA-approved webinar, and you will receive your certificate of completion by Friday. Are there any other health hazards for mineral fibers beyond cancer?
Maybe a trick question. There is no cancer hazard with mineral fiber insulation. The only other hazards, not so much health hazards, are that of mechanical irritation. And we've talked about the PPE to avoid that irritation, temporary mechanical irritation. Probably good, you know, things like long sleeve shirt, gloves, eye protection, long pants, things like that. And then for those applications such as blowing loose fill insulation in a small attic where you're going to experience fiber concentrations greater than 1 fiber per cc, we would recommend the N95 dust mask. But you do not need that dust mask for the vast majority of the exposures where you're going to be working with fiberglass, and that would include manufacturing, installation, renovation, demolition, and then fabrication. We just don't see fiber exposures that are very high at all in those applications.
Excellent. I'll take the next question, and that is, what health hazards are associated from duct particles coming from ducts in commercial buildings that have internal liners? So like we talked about earlier in the presentation, you really don't see a lot of duct particles. This is fiberglass particles breaking off from the duct into the airstream. The particle concentrations in indoor buildings are extremely low in commercial and residential buildings. And you're looking at, like I said, 0.0001, less than 0.0001 fibers per cubic centimeter, which is substantially lower. And then beyond that, you know, these are all biosoluble fibers used in our HVAC duct insulation. So there's not a health hazard associated from duct particles on ducts that are lined with fiberglass insulation. The next question is, what is the role of formaldehyde in insulation? Are we phasing it out, et cetera?
For fiberglass home insulation, bats and rolls, at one time, those rolls were using bats and rolls were using a formaldehyde-based binder. Remember that unlike paper fibers, glass fibers are chemically inert and they will not naturally stick together. So if you're going to have a rigid form, whether it's a bat or a roll, you have to spray a glue on them. That is called what we call a binder. And previously, for fiberglass home insulation, the bonded products had formaldehyde as one of the components in the binder. All of the major manufacturers have moved away from formaldehyde-based binders for home insulation bats and rolls. All right.
The next question is very interesting, and I don't know that we've actually tested it, but the question is, can the insulation provide a safeguard against COVID-19 or other airborne viruses?
Boy, that's a rather topical question there. I don't know of any insulation that is effective against COVID-19 or any other viruses or bacteria for that matter. You know, it's just just don't know that. I know of no insulation that can serve that function or has that ability. And I would tell you that the FTC, the Federal Trade Commission, is really starting to crack down on unsupported COVID-19 claims for products. And I would say you have to remind too, the permacoat lining that we have on our duct liner, fiberglass duct liner, is not there to kill bacteria to improve indoor air quality. It's really there to make sure that any mold or mildew does not intrude into the duct liner. So the antimicrobial agent is in the liner to protect the product, not to improve indoor air quality.
All right. The next question is, what is the difference in the health benefits between fiberglass, specifically in flexible ductwork, and sheet metal ductwork, referring to mold, et cetera? I think right out of the gates, you're looking at not really a difference in a health benefit for either. It's typically, flexible duct is typically used in residential applications, and sheet metal tends to be a little bit more common in commercial applications. But beyond that, if you were trying to compare side by side which one is going to offer me a more health benefit, I wouldn't say that either one has a significant health benefit either way. Bruce, I don't know if you have anything to add to that.
What I might add is that, remember, mold will grow on the dirt or the dust, so that anywhere you're going to get a combination of, the right temperature, a food source in terms of dust or dirt, and some moisture, you can possibly get some mold growth. And so even for an uninsulated bare sheet metal duct, if you do start to see any kind of dust or dirt accumulating on that, you could potentially have mold growing in an uninsulated bare duct.
All right. After the insulation is covered with drywall, how could there be a safety concern?
I don't think there is.
I agree.
And frankly, there really isn't any hazard other than mechanical irritation, even before you rock up the wall.
Excellent. The next question is, how safe is mineral wool?
Mineral wool is safe to manufacture and use when, as we say, certain common sense precautions are taken to avoid temporary mechanical irritation, like long sleeve shirt, long pants, gloves, and some eye protection. Just like glass wool fibers, the mineral wool fibers are sufficiently biosoluble that they do not persist in the lung long enough to present any kind of cancer hazard by inhalation.
Excellent. So the next question is, some people have said that they question how inhaling, quote, glass is not hazardous. Can you please compare fiberglass to the small glass shards that might be encountered, for example, when you break a glass bottle?
I suppose the most meaningful distinction is that remember that glass fibers are very, very small. So that, and we've had this question before where, well, how can glass be soluble? I can put water in a drinking glass and it'll be there forever. The issue is that these glass fibers are very small. They have very small diameters. Some of them 1 micron, below 1 micron. So you're talking about something that's thinner than a human hair. And with that kind of size, your mass to surface area ratio is such that it's particularly susceptible to dissolution, especially in lung fluid or simulated lung fluid. Compare that to shards of a broken glass or something where they're actually, on the scheme of things, they're very large, they're very heavy, and so they would not be capable of undergoing the kind of dissolution that glass fibers could.
Excellent.
If that's helpful.
That is, I think you explained it well. So in your list of definitions, what category does asbestos fall into? And this was referring to our the list that I went through of the vernacular used in this field of study, asbestos falls into the biopersistent category. I don't know if you want to add to that, Bruce.
Well, a couple of things. I mean, we're talking, our webinar here today is talking about SVF, synthetic vitreous fibers, fiberglass and mineral wool. Asbestos is a natural fiber, not a synthetic fiber. And we know, and there's lots and lots of science peer-reviewed articles published for many years that you know, basically help people understand the differences between natural asbestos fibers and then the synthetic vitreous fibers. And it is very well established. All the data show that fiberglass and mineral wool are, shall we say, toxicologically, morphologically, and chemically distinct from asbestos. Although they have some, you know, superficial similarities in terms of they're both fibers. They're actually very, very different, and they have especially very, very different hazards. Asbestos fibers do present a cancer hazard. It's well established. In contrast, synthetic vitreous fibers do not, that are used for insulation, do not present a cancer hazard.
Great. Bruce, can you talk a little bit about what are your thoughts on the consensus that fiberglass and man-made vitreous man-made vitreous fibers diameters, the airborne ones, with the exception of ceramic fiber, are generally large, 1 millimeter, and thus non-respirable?
If you look at insulation fibers, typically they have a distribution curve for the diameters, so that say you have a nominal or design diameter to achieve the thermal and acoustic performance. It should be above kind of the 5 micron diameter respirability, but you're going to have a tail to the left of the mean that's going to be a respirable fraction of the total fibers. So you will have some respirable fibers even with the insulation, glass, and mineral wool fibers.
Excellent. This is an interesting question. What are the precautions for workers who smoke or vape, including THC products? Should they take any additional precautions?
Yeah, the big precaution they should take is to discontinue those activities. We will say one of the things that jumps out at you, for example, when you read Dr. Marsh's 2001 cohort Epi Study update, is that the smokers in the cohort fare particularly poorly overall. They have a much, much higher death rate, and they have an early death rate. So smoking is just really, really bad for you.
All right. This one's new to me, so we might need to take a note on this one, but what is the relationship of fiberglass with PM10 and PM2.5 particulate matter regulated by state environmental regulators?
Well, that's an interesting question. The particulate matter and then the fine particulate matter, especially the PM2.5, there's a couple of, I'd say, a couple of important distinctions between just kind of fine particulate matter as EPA regulates under the Clean Air Act versus, you know, the respirable fraction of the synthetic vitreous fibers. I know one of them is that you can get some of these particles that are vanishingly small, and so that you can see they're not only inhaled, they can actually leave the lung and go into the bloodstream. They're so small. In addition, we haven't really seen any kind of chemical type toxicology for synthetic vitreous fibers. In contrast, I know that with some species of fine particulate that EPA regulates, you get a chemical type of toxicity. in the lung. So there is a big distinction there.
All right.
And I would say, let me add this though too. I mean, we have such a small amount of glass fibers being emitted from the manufacturing sites, so that glass fibers are really not considered fine particulates for Clean Air Act purposes, at the manufacturing sites.
All right. The next one is an interesting question, and that is who sponsored or paid for the scientific studies that were done, and were they not dependent upon industry funding?
I would have to say all of the major studies, animal studies and Epi studies, were funded in whole or in part by the industry by the fiberglass and mineral wool industry through the North American Insulation Manufacturers Association. And it's important to understand that if you look at the journal articles such as the new Epi Cancer Epi meta-analysis that Dr. Agnot is publishing, they do talk in some. They have an informational section in the article telling where they got the funding to do the study. But it's important to understand that what we do as an industry, we provide the funding. The design of the study is done by the scientists. They do the study, and we do not have input on the study. When they are done, they tell us what the results are, and when they have an article written up that is peer-reviewed and ready for publication, they send us the article. They do not send us a draft of the article. We do not give comments on the article.
Excellent. So is there any thought that fiberglass liner will be allowed back into the Airstream in hospitals and schools?
I'm unaware that there's any kind of prohibition.
I don't think it's actually universal. I think it might only be in some jurisdictions. So I'm not entirely certain on that one. The next question is, does rigid foam insulation fall within any of the testing referenced today?
No, we're talking just about the fibrous insulation today.
All right. Has ceramic fiber insulation, high temperature insulation, undergone these same tests?
Yes, there have been, I know, animal studies on traditional RCF, and there have been some morbidity studies on traditional RCF. Johns Manville doesn't make RCF. None of the members of our trade association make RCF, but it is a synthetic vitreous fiber, and so its hazard is really, again, determined by the 3 Ds, dose, dimension, and durability. The traditional RCF is pretty durable, and it does have a fraction that is respirable, and so there is a potential cancer hazard there by inhalation, and that is why IARC in 2001 did not downgrade traditional RCF from 2B to a 3. They kept it at a 2B, a possible carcinogen. To be fair, I would have to add that there are forms of biosoluble RCF today, and my understanding is that they have roughly the same performance as the high temp performance that traditional RCF has, but they are sufficiently biosoluble that they have been successfully exonerated in animal tests.
All right. Does the studies that were talked about here today apply to attic insulation that was installed in 1970? My concern is that these fibers could get drawn into the HVAC system and then delivered into occupied space.
Yeah, that's a good question. It's important to understand that the fibers that were tested at the RCC long-term animal inhalation study were the fibers that were in typical use back in the late 80s, early 90s. But for many companies, such as Johns Manville, our kind of workaday thermal insulation fiber for attics and walls is what we call 901. 901 fiber. In the studies, it's also in the animal studies, it's also referred to as MMVF10, man-made insulation, man-made vitreous fiber 10, and that has been in manufacturing use for many decades. So the chances are that if you have insulation in an older home, it's still going to be biosoluble.
If you have fiberglass insulation in an older home?
Yes, yes.
Just to clarify that. If you have an asbestos insulation in an older home, then you should work with professionals and have that removed.
Absolutely, yeah.
Yeah, so here's an interesting question. What are the long-term effects of insulation or mineral wool to the eye?
Well, one of the things that we do is we recommend that when you're working with fiberglass and mineral wool that you wear eye protection. We do have, if you look at our safety data sheets, we do have some, not only precautions, but some instructions on how to handle if you were to get, a piece of fiberglass or glass fiber in your eye. And I think a lot of it has to do with just irrigating it out.
All right. What in the lungs or respiratory system would cause the breakdown of fibers to either dissolve or break into shorter fibers to allow the fiber to be carried away? This was the macrophage that Bruce had discussed earlier. You have macrophage cells all throughout your body, but they are responsible for finding those particles, fibers, anything that shouldn't be in your lungs, and dissolving it and removing it from the system.
But, understand that extracellular lung fluid is not like distilled water. It has various chemical components in it that promote the dissolution of any respirable glass fibers. They have things like, citrates and phosphates and other chemicals that do help promote that. In addition, remember that the macrophage, when it tries to engulf these glass fibers, it releases low pH enzymes, acids, and that also drives dissolution of the fibers. And for the biosoluble fibers, that's one of the real mechanisms at work where we see this the breaking up of a longer fiber into shorter fibers that are then carried out. It has to do with those macrophage enzymes, those acids that eat at the fiber too.
All right, and our final question, is there any progress or research being done to eradicate the fiberglass mechanical irritation on skin?
The mechanical irritation occurs largely because of the diameter of the glass fiber. The larger the diameter to a certain point, the greater the potential for some of that temporary mechanical irritation. We know that when you have glass fibers where the diameters are very, very small, such as some of the microfiber products that Johns Manville makes, you can touch those, feel them, and there's no irritation at all. So it has to do, that has to do with the diameter of the fiber. And that's why if you're going to get some of those a little bit larger fibers in insulation wools, they can cause that temporary mechanical irritation. And that's why we suggest people use gloves and a long sleeve shirt among other precautions to avoid that irritation.
Excellent. Well, we had a lot of great questions today, and I want to thank everybody who decided to stay on with us and everybody who participated in our webinar today. As I mentioned, you will receive a survey immediately following the webinar, and we'd appreciate it if you take your time to offer your feedback. If you have any additional questions that you weren't able to ask, you can submit those in the survey as well, and we'll respond to you directly via email. And also, please keep an eye on your inbox for your certificate of completion. That'll be sent to you via email by Friday. And again, you can submit those for AIA credits if you'd like to. Recording of the webinar will be posted to our website on the source in the following week. And as soon as it's live, we will send you a link to the webinar directly so that you can watch it again if you'd like, or share it with your colleagues who you think might find it interesting. So thank you very much for attending today. We hope you all stay safe, wash your hands, social distancing, and all that good stuff. So take care and enjoy the rest of your week.